Hello everyone, welcome to the video lecture series on set theory. In this video lecture we shall be learning about the different laws of sets. Okay, now what are they? They are the fundamental rules in set theory that help you to solve the larger results of set theory, okay, or the logical statements which are made, those can be tackled with the help of set theory rules. Okay, so let me show you the laws which are there. Now here in these laws I am going to give you the names also, because many of the time the names are given to us and we may not recall the property associated to that name. So here I am showing you the name along with what does that name mean. Okay, so the first one is A union the null set is same as A. Okay, and the second one says A intersection the universal set U is again A. Now be very careful over here, because these two rules are called identity laws. So what do they mean is, how do you get the same set out of that operation of union and intersection? So when you do the union with the null set, a null set is a set smaller than the given set, okay, or a set whichever you have. Okay, it is going to be smallest. Null set is the empty set, so it's having hardly any reference in front of the given set. So whenever you do the union, you are always going to get a larger set in front of it. So that's why you have A over here. Now use the principle of duality that we had studied in the last lecture. Okay, so what does that say? That replace union by intersection and null set by the universal set. So when I replace union by intersection and null set by universal set, I still get the same equation. Okay, so A intersection the universal set is A. Now universal set is the largest set under the consideration, whatever we are considering. So A is going to be the subset of that. Okay, so whenever you do the intersection of a larger set and the smaller set of that largest set, you are going to get that smallest set back. Okay, so that's why this identity holds. Okay, so this is called identity law. The next one, now this is domination law. It says a union with the universal set is the universal set, and a intersection with the null set is null set. Okay, so this is called domination law. The next one is a union with A. When you take the union of the set with itself, you are going to get A again. Okay, and when you take the intersection of the set, given set A, with itself, again you are going to get the same set back. Okay, so this is called idempotent law. Now this is a very crucial thing. A complement, which is also denoted sometimes by the bar over the head of A. So a complement of the complement is the set again. Okay, so remember here, I'll show you the complement when I take here. Okay, I'll just give a note here. See, if U is the universal set, okay, if I take universal set, okay, then A complement will be denoted as U minus A. Okay, and when I take the complement of this here, okay, so what will happen, it will become complement to this. So that will give me, again I'll go back to A, because you have only two sets, right? If in generally when you are talking about, this is A and this is the, if this is the union, okay, the universal set, then you have, this is U minus A. So if I take A complement, then this is there, and if I take U complement, okay, the complement of U minus A, sorry, U minus A, if I take, then I'll go back over here, I'll come back. So that's how the whole complementing process is about. So they say that A bar of bar is going to be A again. Okay, now these are called commutative laws, that says A union B is same as B union A, and A intersection B is same as B intersection A. So you can write either way out, okay, so need not worry. Now what I want you to recall, that these are very similar to your and or in Boolean algebra or lattice theory, if you have already studied anywhere. Okay, if you haven't, then need not worry, but these are there, right? Those of you have studied mathematical logic, then this is similar to that. Okay, so okay, let's go for the next set of laws, that are says yeah, we have already seen the commutative laws. Okay, now let's go for associativity laws. Okay, the associativity means you are able to shift the brackets. So what do it mean? That A union B, okay, first, and then you unite it with C is same as A union done with B union C. Okay, and then it also says A intersection B with B intersection C is same as A intersection B done first and then you intersect C. It's okay. Alright, now these are distributivity laws. The first one, okay, the 12th law that you see is called right hand distributivity. And the 13th one is called the left hand distributivity law. Okay, left hand distributivity law. So what does it mean to say here? It is A intersection B union C is same as A union C intersection with B union C. Now observe carefully this law. All these laws are very important and we can prove them. Okay, but right now we will first try to understand them, what these laws are trying to tell us. Later on we will go for proving them. The other alternate version of the same can be derived with the help of the duality principle. Okay, and yeah, you can replace a union here inside and then intersection outside, and then the whole duality principle will give you a one more set of rule. Okay, now let us see the other one. A union B intersection C is same as A union B intersection with A union C. Okay, now this is left hand distributivity. Okay, now we have already dealt with the De Morgan's law. What I want you to understand, that as I had told you, there are these two rules. Both of them, if you remember, they are derived from this one. The first one you need to know. The second one is derived from the duality principle. Replace union by intersection and intersection by the union. You get your answer. Okay. Now these are absorption law. Yeah. So they say that A intersection A union B is A. Okay, so A intersection A union B is A. That means A union B is the larger set and A is a smaller set, obviously, because A union B is always larger than A. So, and if you intersect A to that, so the smaller set A is going to be your output, and A intersection B, okay, union with A, when you do, A intersection B is a smaller set than A. Remember that. Here if you want to know that A intersection B is a subset of A, and it is also a subset of B. A intersection B, B is a subset of B. Okay, if you can note here, then A union B, A union A intersection B is going to be A. Okay, so that is one thing. Yeah, this is a very crucial. If you see here, if this is A and this is A complement, then together A and A complement give you the union. Okay, the universal set, the universal set they are going to give you. And A and A intersection, A intersection A complement, there is no common between the two, A and A complement. That's how they are defined. So they are complement laws. So these are all laws from my side for the set theory. Okay, and I have tried giving you their names over here. You remember them, you will get hold of them again and again as you use them. And yeah, we will try to draw their diagrams and try to understand them. These are, I have given you with 1 and 2 sets, let's say A and B and C. These laws further can be extended to finitely many sets or countable number of sets too, but they are in little bit advanced version, so we'll stick to these initially. Later on, as we start using them, we can expand the uh, periphery of our understanding and the laws. Okay, so slowly we will go towards expansion of these laws and De Morgan law and other things. Okay, so till then, thank you for joining in, and we shall see detailed concepts in coming video lectures of set theory. Thank you.